Assalamualaikum and good day to everyone. Today we continue our new lecture on general principle on static. Well, the objective of the lecture today is to understand what is the fundamental concept, what is the basic quantities and idealization that can be applied in mechanics. And number 2, to describe what is the Newton law in motion and gravitation. And the third objective is to review the applications of SI unit. Overall, the expected outcome of this lecture, students should be able to implement the fundamental concept and Newton's principle in solving the mechanic application. Next, the chapter outline. Today, we're going to study what is the definition about mechanic, and then what is the fundamental concept, unit of measurement, what is the international system unit, and then next we do the examples of calculation in terms of numerical and also the prefix. Okay, number 1, what is the mechanic? Mechanic is the branch of the physical science which describe or predict the condition of rest or motion of bodies under the action of forces. So here mechanic, in study mechanic, so we can have divided into 3. So number 1, rigid body. So in this rigid body, we're going to study about what is static, under static and also under dynamic. Under static, we study the rigid body, equilibrium of bodies at rest or move with a constant velocity. And then next, under dynamic, we study the rigid body that subjected to accelerated motions of body. So here we study in engineering mechanic. And then for other two of mechanic, for the deformable body, you will continue this study in the mechanic of material. We call it MUM. Okay, after you complete the engineering mechanic, then you continue with the MUM. And then under the fluid, so under the fluid, you will study first compressible fluid, you study under the fluid mechanic, and then incompressible fluid you will study under the hydraulic. So this is the definitions about the mechanic. Next, we study about what is the basic quantities. Now normal in our life we have 4 basic quantities, right? So number 1, length. So what is length? Length is to measure distance and geometry of property. So usually, what is the unit you measure length? Okay, next, time. So what is time? So time is the durations of travel. And then the third one is mass. So what is mass? Mass we measure the quantity. Alright, so normally what is the unit when we measure mass? So kg. And then the last one, the basic quantity is force. So what is force? Force is the action one body on another. So what is the unit we use for force? So that's why we need to know what is the this basic quantities. Okay, next is about idealization. So idealization means that we represent the actual body into the particle, into the rigid body, and then the concentrated force. So what is the difference between particle and rigid body? So here, under the particle has a mass but no size, and then particle has geometry of the body will be negligible. And then what is the rigid body? So under rigid body is a combination of large number of particles, and then all particles stick from one and another. And then rigid body is suitable for analysis. So normally when we have the actual structure, we only represent in particle. So this is the particle. So the particle you just sketch this one, the circle one. So this is we call it particle. And then concentrated force. So So concentrated force means that loading effect acting over the surface area of the body. So let's say we have a beam here and then subjected to the loading. So this is our loading. Right. Next, Newton's law. So what is the first law of Newton? So here, first law stated that a particle is in the rest position, means rest position is no motion, or moving in a straight line with a constant velocity, or as in equilibrium. So means that first law of Newton stated that particle is in equilibrium. Equilibrium means that all forces is equal to 0, acceleration is equal to 0, and the velocity is equal to constant. So this is the particle is in equilibrium. Now this is the Newton's first law in action, the examples of the first law of Newton. So why do passengers get thrown to the side when the car they are driving goes around a corner? Okay, so now we observe. Alright, so we observe first what happened before the car turns. This is first before the car turns. What will happen before we take a corner? So before the car start turning, both the passengers and the car are travelling at the same velocity. So means that both car and driver in the same position. And then what happened? So what happened while the car turned? So what happened? So when the driver turns the wheels of the car, which then exert a force on the car and the car turn. So this force act on the car but not the passenger. Hence, by Newton's first law, the passenger continue moving with the same original velocity. So we call it inertia. Okay, and then here, why passengers get thrown to the side? So if the passenger are wearing the seat belt, we exert a force on the passenger until the passenger velocity is the same as the car. So like this. So without a seat belt, the passenger may hit the side of the car. So means that here, both the car and the person are travelling at the same velocity again. So this is how we can apply the first law of Newton. Next, Newton's second law. Second law of Newton states that a particle is in the motion or unbalanced force, which produce an acceleration in the same direction as the force and magnitude. So here, Newton's second law stated that F is equal to ma. So F is a force, m is a mass, and a is the acceleration. So here, what we can relate with our everyday life by using this second law of Newton. So for example, if you use the same force to push a lorry or a car, so which one will be more easier? So for example, the car, we have more acceleration than the lorry because the car has less mass, right? And then another example. So for this example, you want to push this one. You want to push the trolley. So this is the empty trolley. So this is the force, and this is the mass, and this is the acceleration. So if you push empty trolley than a full trolley, so which one is easier? So definitely the empty. So now, what is the third law? So Newton's third law stated that action and reaction force between two particles are equal, opposite, and collinear. So you can see here, so we have a force, okay, force on A, particle A, and then we have a force on particle B. So we can write F is equal to negative F here. And then when there is a reaction, there will be a reaction. So what is the examples of the Newton's third law that we can apply in our everyday life? So for example, let's say you jump. So what will happen? Your legs apply to a force to the ground, and then the ground applies an equal and opposite reaction force that propels into the air. So let's say this is your foot. Okay, let's say this is your foot. Right, so this is the ground. So this is the force from the ground, and this is the force from the foot. Right, you push down. This one push down. Push down. This one push up. Right, okay, the next one. Let's say this is wall. So you hit, this is you hit wall. And then, let's say you hit the wall with a force. And that exert an amount of force is written by the wall. Right. Okay, and another example is that when you're rowing a boat, you want to move forward on a boat, right? So what you should do if you want to move forward? So definitely, you pedal by pushing the water backwards, then causing you to move forward. So for example, like this. So you want to move forward, so there will be your action, and there should be the reaction. Okay, next, Newton's law of gravitational attraction. So what is the universe law of gravitation state? So it states that a particle attracts other particle in the universe using gravity force, whether direct proportional to the masses of objects or inverse proportional to the square of distance between their center. So this is the Newton's law of gravitation. So we have force, we have universal gravity here, and then we have mass. Mass means that we have two particle, and this is mass 1, and this is the mass 2, and this is the distance in between two particle. So who can say that this equation is come from who? This idea. Can you remember? That is a popular story about this law. So the popular story about this law is related to this one. So what is this? What is this? This is the popular story about the Newton was sitting under an apple tree. An apple fell on his head, and he suddenly thought of the universal law of gravitation. Is that right or no? So probably actually Newton observed an apple fall from a tree. So the apple is accelerated since its velocity changes from 0 as it's hanging on the tree and moves toward the ground. Thus, the Newton's second law stated that there must be a force that acts on the apple to cause this acceleration. So the force called gravity, and the associated acceleration called acceleration due to the gravity. So this is the law of the universal law of gravitation. Next, weight and the gravitational force. So weight is the force influenced by only gravitational force. So how? So normally in language, mass and weight are often used to mean the same thing, but in reality they are reflected by quite different things. So normally we call weight if it's really weight is really just the gravitational force exerted on object on a certain mass. So what can we can say that here we have the weight. Now we have, let's say this is our earth. Okay, now this point earth, and this is the particle. So now let's say this particle has a mass, and then this earth has a mass of earth here, and then the between this one is r. Okay, so weight of the object of mass at the surface on the earth is obtained by the multiplying of the mass m by the acceleration due to the gravity g at the surface of the earth. So the acceleration due to the gravity is approximately the product of the universal gravitational constant g. So here you can say that m is the mass of particle, and then me is the mass of earth. So how weight is become like this? How is weight is equal to mg? It is because here, so when we subjected to the gravitational force, so you can see that this one, so it's become this g, this gravity. So based on the sea level and latitude of 45 degree, so this g is become 9.81 meter per second square. So that is what it's become. This weight is become mg. So m is the mass and g is the 9.81. We call it a gravity force. So what we can say about mass and weight? Mass is a measure of how much material is an object. Okay, and then weight is a measure of the gravitational force exerted on the material in the gravitational field. Thus, mass and weight are proportional to each other with the acceleration due to gravity as the proportional constant. Next, what is the difference between F is equal to mg and F is equal to ma? So, when F is equal to mg, g is a value for understood to be the acceleration due to the gravity on Earth. And then F is equal to ma is the general formula that could be applied to all Newton forces, not just for the gravity. Next, units of measurement. So commonly, except US, we are using the international system SI. So in the world, we are using the SI unit system that been applied as a standard measurement unit for all measurement. So here we have, remember what we have a basic unit. So in basic unit, we have length. So length we measure in meter. And then time we measure in second. And that mass we measure in kilogram. And then force we measure in Newton. So in engineering mechanics, throughout the engineering mechanics, everybody must remember what is the measurement unit for length, time, mass and force. Understand? Next, in US, So in US, they are using the customary system unit, FPS. So what is the difference between FPS and SI unit? So here we have basic unit for length. They are using unit feet. And then time, they are using second. Similar, right? And then force, they are using pound. And then the last one, mass. So mass here is become derived unit. So the unit is slung. Okay, so mass that is accelerated by 1 feet per second square when a force of 1 pound is exerted on it. So this is the different from the previous one. This is the SI unit and this is the FPS unit. Next, 1.4 is the international system of unit. So table 2 show the prefix. So the purpose of prefix is to convert the very large or small quantity into a proper unit. So this is the prefix and this is the value and this is the standard form to represent the value and this is the symbol. So you can see here for the prefix all prefix is in the lower letter except for these three. So this tera, giga, mega symbol is in the capital T, G and M. And then for kilo, deci, centi, milli, micro, nano and pico here. Okay, so it will in the symbol is in the lower letter. Kilo, deci, centi, milli, micro, nano and pico. So here is the value. So everyone here should remember, okay, when we have tera here, so we need to know the value. So the value for the tera is 10 to the power of 12. Giga, what is the giga? Giga, the value is the 10 to the power of 9. And then mega. So mega, the value is the 10 to the power of 6. And then kilo. So kilo is 10 to the power of 3. Okay. This is for the larger quantity. So next is for the small quantity. So this is for the small quantity. So for the small quantity, we have deci. Deci 0.1 represent by the 10 to the power of -1. And then centi represent by 10 to the power of -2. Milli, here is milli represent by the 10 to the power of -3. And then we have micro represent by 10 to the power of -6. And then nano represent by 10 to the power of -9. And then the last one we have pico we have 10 to the power of -12. So everyone here must remember the symbol for the prefix. So this one, the symbol for the prefix, and also the value for the prefix. Next, we continue for the example. This is the examples of using proper prefix. So here we have for lunch quantity, for example, we have 5 million Newton. So we convert into a proper prefix, it become 5,000 kilonewton and or 5 mega Newton. So here, how we convert this prefix? Okay, number one. So here we have a 5,000. Okay, this is the kilo and this is the unit for force, Newton. So this one, K, you remember K, the value of K is 10 to the power of 3, right? So here, so we have 5,000 times 10 to the power of 3. So 10 to the power of 3 represent for the kilo. So that is why it should become like this, 5,000 kilo Newton. And then next we have here 5 mega Newton. So we must remember that 5 meganewton. So mega is represent the value of 10 to the power of 6. So now from the 5,000 kilonewtons, it's become 5,000 times to the power of 3. So this one times 10 to the power of 3. So here, so that's why we have this 10 to the power of 3 become 10 to the power of 6. So that is why 10 to the power of 6 is represented by the mega. Understand? Okay, next we have small quantity here. So small quantity here, m is meter. So when we convert to the proper prefix, it become 4 millimeter. So we need to identify. So this is the symbol for prefix milli, and this one for the unit. So here we have 1, 2, 3. So here we have 4 times 10 to the power of negative 3 unit meter, and then 10 to the power of negative 3 is present for the milli. So this is why it's become like this. Next, this is the rules of using for solving prefix. So number 1, multiple units must be separated by the dot. So for this example, we have Newton is equal to kilogram dot meter per second square is equal to kilogram dot meter dot second power of negative 2. And then next, the exponential power of the unit represented for both unit and prefix. So it means that when we have a power, so like this, when we have example mu Newton power of 2, it means that both prefix and unit is subjected to power exponential. So we can have that like this, mu Newton, okay, in bracket exponential 2, or is equal like this. Okay, understand? Next, convert all prefix into power of 10. So for this example, we have 50 kilonewton times 60 nanometer. So we convert into power of 10. So it become 3000 kilonewton nanometer. So it's become like this. Okay, next. Symbols for prefix are in the lowercase letters except for tera, mega, and giga. And then the last rules, with exceptions of base unit kilogram, avoid use of prefix in the denominator of composite unit. For example, like this, Newton per millimeter. So become like kilonewton per meter. And then the second one, meter per milligram. So it should be mega meter over kilogram. So we must remember this because we want to solve the problem after this. Okay. Now, before we do the calculation, you must remember this rule. So number one here, dimensional homogeneity. So dimensional homogeneity means that everything must be in the same unit. Means that if you are using this SI unit, so everything should convert into SI unit. So if the question in the FPF unit, so we must use the FPS unit. So normally in practice, we use both SI unit and FPS. But in exam, we only use for the SI unit. And then the number 2, significant figures. What is the meaning of significant figures? Okay, for this example, we have 26,300. So this is the 5 significant figure. How we convert to become the 3 significant? So you can use like this, 26.3 10 to the power of 3. So it becomes 3 significant, 1, 2, and 3. Okay, another example is like this. So now we have this number, we have 6 significant, we have 0.000662. So how we convert into 3 significant figures? So you can have 0.662 times to the power 10 negative 3, or you can have 662 times to 10 to power of negative 6. So it also become to the 3 significant figures. And then the last one is rounding numbers. Okay, rounding numbers. So common practice, you can round into 3 decimal place. So what is the decimal place? So for this example, we have 0.1245. Let's say the question state that rounded to the 1 decimal. So 1 decimal, it becomes 0.1. 2 decimal, 0.12. 3 decimal become 0.125. So must remember, this is 1 decimal, this is 2 decimal, and this is 3 decimal. So in common practice, we solving the answer up to 3 significant figures and also to the 3 decimal place. Okay, let's do the example number 1. Solve the problem below and express in SI unit with appropriate prefix. So here we have 3 questions, A, B, and C. So we go for A first. So first, before we do the before we solving the question, so you need to identify which part is prefix and which part is unit. So this is the prefix and this is the unit. This is the thing that everyone need to understand. Okay, so the first step, we need to change the prefix to become the value. So here we have 50 millinewton times 6 giganewton. So we need to change the milli to become the value. So the value of milli is 10 to the power of negative 3. And then the newton we maintain. And then the next, giga. So we have giga here. Giga value is 10 to the power of 9. And then we maintain the newton. So after we convert the prefix into the value, then the second step, so this is the first and this is the second. So the second step, you can solve the mathematical. So now you can solve 50 times 6 become 300. And then the value for the prefix here, 10 to the power of 3 times 10 to the power of 9 is become 10 to the power of 6. And then don't forget for the unit. So this unit, Newton times Newton, become Newton exponential 2 here. So here you must remember again, if we have exponential in unit, so we need to have the exponential in prefix. So 10 to the power of 6, so it's become 10 to the power of 3 exponential 2 here. Okay, next, step 3, we need to simplify, pack the exponential into the prefix symbol. So for this case, 10 to the power of 3 is what? 10 to the power of 3 is kilo. So here you can write back 300 K power of 2 Newton power of 2 here. But at final answer, you only can write this K power of 2 become K only, because we understood that kilonewton power of 2 is become 300 like this, kilo power of 2. Okay, so we can simplify like this. Next example, we have 400 millimeter times 0.6 meganewton exponential 2. So first step, okay, you need to identify where is prefix and where is unit. So this is unit and this is prefix. Also, this is prefix and this is unit. Okay, and then the first step, we need to change the prefix into value. So here milli, right? So milli represent by the 10 to the power of -3. And then don't forget to maintain the unit. And then next, you must remember that here is the exponential 2. So you must remember that everything inside here must exponential by 2. So here we should have 2, and then mega also we need 2, and then this is Newton is 2. So this is the value for the mega. Alright, then you can solve the second step. You can solve the mathematical. So you must remember 0.6 power of 2 is become 0.36, and then 10 to the power of 6 exponential by 2 become 10 to the power of -12, and then Newton exponential 2. Then after you convert everything, then you can solve by mathematical. Then you can have 144 times 10 to the power of 9, okay, meter dot Newton power of 2. So must remember about the this power. So now you can have, so the prefix you can solve into the this one, simplify into the prefix. So here we can answer that like this. Okay, you can have that 144 kg meter dot Newton power of 2. Okay, also from this you can solve like this. So you can do by your own. Next is the last example. So we have here 55 mega Newton power of 3 divided by 100 gigagram. So from here, first you need to identify this is the prefix and this is the unit, and this is the prefix and this is the unit. So step 1, okay, value of prefix, right? Value of prefix. Second step, solving the mathematical, and number 3, simplify prefix. So you must remember the step. So here also you must remember about this one, exponential. Okay, so here you can convert the meganewton becomes this value 10 power of 6. Okay, and then the 900 gigagrams to become 900 10 power of 6 kilogram. So here you can see that from gram become the kg here. So that is why it's become 10 to the power of 6 here, because we have 900 giga, actually 10 to the power of 9 gram. But we need to, from the based on the rules given, we need to change the grams to become a kilogram. So that is why from 10 to the power of 9 it's become 900 times 10 to the power of 6 times 10 to the power of 3. So this one we give for the kilo. So that is why it's become like this. Alright, so next you must remember about this exponential. So here don't forget to have the 10 power of 6 power of 3 here. Okay, next you can solve the mathematical. Okay, after you solve, then we need to simplify. So you must remember when we have 10 to Newton power of 3 here, so this 10 to power of 9 must change into this. So 10 to power of 9 become 10 to power of 3 power of exponential 3 here. So this 3 is kilo. So from here you can write like this. So it's become 61.1 kilo Newton power of 3 divided by kilogram. Well, that's all for today. Hope you can achieve the outcome of the lecture, which is number 1. You should be able to understand what is the fundamental concept of mechanics, including basic quantities, unit that be introduced and applied in the mechanic. And then the second one, you should thanks to the Sir Isaac Newton, because we applied a lots of Newton's law in motion and gravity that have been identified and implemented in the mechanic, and also we have been using in our daily activity by using the rules, Newton's first law, second law and third law. So please do the tutorial and see you for the next lecture. Bye.